right. So here we are working on one of these. So, all right, so let me remind you how we do these. Sorry, let's go. So how do we do this? Remember, this is the two equations, two unknowns. Two equation, two unknown. So we got to use the basic a sub n is a1 plus n minus 1d. So that's the thing we're going to use, and then we're just going to plug in what they're saying. Remember, I was kind of emphasizing that the ordinal, which means like the thing with the th, that's called an ordinal because it implies an ordering, right? Tenth instead of just 10. So if you have a number like 10, that's normal, but tenth is what's called an ordinal, meaning it implies an ordering, right? So those are always in, because that's where students get confused. I want to help you. Once I started saying that a few years ago, it started helping. So ordinals are always your in. That's how you recognize those. So when they say the 10th term is 0, they're saying that when you take this formula and you plug in for 10, and let's do that. In, right there, I put in the 10. It will equal, what is the 10th term? It is 0. So far, so good. And then you just use that formula again. Second time, they're saying 70th, that's in again, right? Remember, ordinals are always in. 70th term is equals negative 180. So a sub 70, right? See how I'm always letting the n be whatever the ordinal is? So a1 plus 70 minus 1 times d. Good so far? It's making sense. So again, the n is the ordinal, plug that in. So now we have, notice here we have two equations that have two letters. Let me clean them up. Let me, clean them up. A1, so 10 minus 1, that's 9d. And 70 minus 1, what's that? 69d is negative 180. See there? It's real easy to see there. Two equations, two letters, right? Two equations that both have a sub 1 and d. So two equations with two letters, A1 and B, A1 and B. So how do we solve two equations with two letters? Well, you know, system of equations. Easiest way is just to run a negative sign through that top one, because then the A1s will cancel. So that's what I would do on these every time. Just run a negative sign right through that top one. Negative, negative, and then negative 0, which that's just 0. And then add them up. And the A1s cancel. 69D minus 9d is 60d, and that's minus 180. We good to there? Solve the two equations with two letters. Divide by that 60. And so d is minus 3. D is minus 3. So we got d. Now we get A1 by plug it in, wherever you want to plug in, huh? So let's take it up here maybe. Plug in. D is minus 3 to whatever equation you feel like. I'll just grab this one here. Maybe that A1 plus 9D is 0. Plug in the minus 3. So A1 plus 9 times minus 3 is 0. Am I on the screen? Just barely, huh? A1 minus 27 is 0. So A1's 27, right? So we got A1, we got D, we got our formula. Let me bring it over here now to finish it up. So again, the formula is A1 plus n minus 1d, 27, A1, 27, plus n minus 1, and d, we've already found, is negative 3. So we got d, we got A1. Is that good? To there? And so now just distribute. That minus 3 goes boom, boom. Minus 3 and plus 3. And so that's 30 minus 3n. There it is. Does that make sense? So they're asking for the A1 and the D. right here. So the A1 would be, what is the A1? The A1 is 30, right? Oh no, 27, huh? I'm confused. The A1 back over here was 27. The D was -3. This is 2 parts remaining. What else do they want? And now they want the recursive. So yeah, so that's right. What you're saying is exactly right, Robert. So they want, first off, the last question is going to be that. That's not the recursive. That's the normal formula, which they're going to ask for last. But they're going to ask for the recursive. Now remember, we did 1, maybe 2 of those last time. What's a recursive? It recurs. In other words, it goes back to the previous term. In other words, it's find the a sub n term in terms of a previous term. Well, basically, what's happening here every time is you're taking the previous term, a sub n minus 1. Remember that means previous? Remember how we talked about recursive? A sub n minus 1 is 1 less than, right? It's back a term, right? N minus 1 is back a term. It's the previous term. You tell me in this sequence, every time the difference is -3. Does that make sense? In other words, maybe this will help. This 27 is the first term, right? 27 is a sub 1. That's what it means, first term. A sub 1 means first term. Let me write it up here. So 27 is the first term. And then the difference is down by 3 every time. So the next one would be 24, 21, 18, and on you go. It's going down by 3, right? The difference down by 3, down by 3. That's the D, the difference, the jump from term to term. So it's going down by 3 every time. So what? Well, that means if you want to know any term, you take the previous term and you subtract 3, don't you? You just subtract 3. That's what the recursive formula is. And this one is the normal formula. I could talk more about that. Basically, the recursive formula only tells you how to find a term from the last term, right? This says, want any term? Take the last one and subtract 3. Right? You want to know this term, 21, the third term? Take the last one, 24, and subtract 3. Yeah, that's true. That's what the recursive formula says. But that's actually not as helpful as the normal formula. Why not? Because how could you go to the 100th term? What if I said, I want to know the 100th term right now? Boom, jump to the 100th term. Can you tell me the 100th term? Well, with this, just plug in 100 here. It's whatever 30 minus 3 times 100 is, right? This is the n formula. I call it the normal, but it's the n formula. You can jump to any term automatically. This is like a CD, and this is like an old cassette tape. You know what I mean? Right? Remember the old cassette tapes where you couldn't jump wherever you wanted? I don't know if some of you guys are too young for all that. But yeah, if you wanted to, your favorite song was at the end, or whatever you wanted to listen to was at the end, you had to fast forward through all the other stuff, right? But with CDs, you just jump where you want, or DVDs, right? So recursive is like a cassette, right? You can only go one. If you want to know the 100th term, you'd have to know. It says, well, all I can tell you is you got to tell me the term right before, and then subtract 3. We'd have to know the 99th term, and then subtract 3, and that would be the 100th term. Well, we don't know the 99th term. We can't get there. We'd have to go all the way down the line. Whereas with the n formula, you can just jump to any term you want, like a CD. That's the difference. Those are the two formulas they want. Make sense? So how do we do the recursive then? No, this is the recursive right here. Yeah, let's go type it in. A sub n minus 1, take away 3. Yeah, it means, so recursive means previous term. A sub n minus, this means previous term because it's 1 back. It's n, take away 1. It's previous term minus 3. So the recursive formula is always going to be a sub n is a n minus 1 plus d. You might think, no, it's minus 3. Well, d is -3, so plus a -3, that is minus 3. It's always going to be the difference. It's always the previous term and then the difference. Let's go. Oops, hit the wrong one. That's not what I wanted either. Is -2 and the 22nd. They did the 22th. The 22th. I guess that's an algorithm thing. Anyway, 22th term is -14. So try that one. Same kind of thing. So 2 equations, 2 unknowns. The basic equation is a sub n is a1 plus n minus 1d. So let's make it 10. So remember the ordinals, like the th, the 16th, that's your n, huh? So a sub 16, which is a1, plus, whoop, the n is 16. And that is negative 2. Is that good for that first equation? Everybody see that? So I plug in the ordinals, the ordering numbers, those are your n's. And then the second one, a sub 22. That is equals negative 14, huh? We good to there? So then I'm going to clean those up a little bit. That's a1 plus 15d is negative 2. a1 plus 21d is negative 14. We good to there? Two equations, two unknowns. Right? Run a negative sign through the top one. Run a negative sign through it. That'll make the a1s cancel. Negative, negative, and then make that a plus 2, huh? So I just multiplied the top equation by negative 1. Why? So that when I add them, the a1s will cancel. Everybody see that? So I multiplied through the top equation by negative 1. So that when I add them, the a1s will cancel, and I'll get 21d minus 15d is 60. And this is negative 14 plus 2, which is negative 12, huh? Good to there. Divide by 6. D is minus 2. D is minus 2. Okay. So D is minus 2. We got our D. What do we do? Plug it in now. Bring it over here. Plug in. Plug in D is minus 2. Where? To any one of these equations you want, really. So I'll grab this one, let's say. A1, before I changed its signs, just use it the way it originally was. Am I on the screen? No. I'm off the screen. I think that thing moved today, didn't it? It does. It moves day by day, doesn't it? Because sometimes I have the whole width of my iPad, sometimes I don't. And I just, day by day, I got to look up and see where we're at with the projector. All right, so negative 2. Plug in that D. I'm still not squeezing that thing in. It really moved on me. So let me try again. A1 plus 15D is negative 2. There we go. All right. Plug in that D right there. A1 plus 15 times minus 2 is minus 2. All right, so that's A1 minus 30. It's minus 2. Add the 30 to both. A1 is 28. So I got A1 and D. We good there? So I can answer the questions. A1 is, that they ask. And then they'll also, can we do the recursive real quick? Go ahead, let me give you a chance to do that. Go ahead and write the recursive. Remember, the recursive is always going to be A sub n is an minus 1 plus D. For these. In other situations, it'll be different. But for these linear ones, that's what I mean by these. These are all just linear ones. They're just like mx plus b. Except it's an A1 and a D, but it's the same thing. It's linear. Then the recursive is always going to be A sub n minus 1 plus D. What's D? Negative 2. So plus negative 2 or minus 2, same thing. So there's the recursive formula. That good to there? And then the n formula. Wait a minute. So the n formula is going to be A sub n is A1 plus n minus 1d. So they're going to ask you for both formulas. So here's the other one. The recursive formula and then the A sub n formula, which is going to be A sub 1, now I know it, 28 plus n minus 1d. D is negative 2. So now distribute, boom, boom, and you get A sub n is 28 minus 2n plus 2. A sub n is 30 minus 2n. So there's the A sub n formula, 30 minus 2n. There's the recursive formula. There's everything they want. Is that good? We okay on that? Two equations, two unknowns? All is well? All right. Halfway through here, we will change formulas. Okay, notice now that they're adding them, aren't they? They're adding these up. Right? They have plus signs with them. So, what does that mean? Plus signs on everything. So it's a new formula. I got to give you a new formula. S sub n is, I got to remember the new formula.
N over 2.
Ah, thank you, Robert. N over 2, A1 plus AN. Oh, yeah, and I want to show you where that comes from a little bit. Let's just use it first. You know, again, I never like formulas that seem like magic. So there it is, poof, magic. There's the formula we use. We'll try to get the magic later. But let's just use it for now, get comfortable with it. So there's the formula. So remember, we have the old A sub n, which is A1 plus n minus 1d. So those are the two that I will give you. Well, there's going to be three others as well, at the top of exam number 4. Right? And then 3 others as well. But those are the two from this section. That'll be right at the top of exam number 4. The A sub n and the S sub n. And then in the lecture we do after Easter break, when we come back on that Monday, I'll give you another A sub n and S sub n. The next section, 12.3. It's going to be all the same stuff, except instead of adding or subtracting the same number from term to term, it's going to multiply or divide the same number from term to term. Those are called geometric sequences, but it's all pretty much the same other than that. We're going to have an A sub n formula and an S sub n formula in that section as well. So it's good to kind of set in your mind right now. A sub n is always used to find the items with commas. In fact, let me write that over here. This would be like A sub n would be used when you have like 11, 14, 17, dot, dot, dot. S sub n is used when you have 11 plus 14 plus 17 plus dot, dot, dot. See the difference? Plus signs in the middle, not commas. That's the difference, right? Up to now, if you look back, let's look back for a second. Everything we've been doing has been having commas in the middle, right? Well, they didn't show anything there, but going back to here where they were actually listing them. Oh, that's it. I can't. That was yesterday's lecture, wasn't it? So I can't go there. But anyway, if I could, you would see they all had commas. That's A sub n. So this is how you'll know on the next exam, exam 4. You look at a question, if they have commas between them, you go, oh, I need one of them A sub n formulas. If they have plus signs between them, you go, oh, they're adding them up. I need the S. What do you think that S stands for? Sum. That's what S stands. Same thing as the Greek S, right? Sum, right? And next semester, you're going to get this. Guess what that is? It's a big S, isn't it? That's the integral symbol. That's right on the front of the calculus book. That's calculus. It's a big S. It's a big, stretchy S, is what I always call it. Right? It means add them up. Area under the curve. It's adding up boxes of area under the curve. It's a little more fancy. Have you ever thought about it for a second? That all of math is really adding? It is. Right? What do you mean? What do you mean? There's subtraction. Well, what is subtraction? 3 minus 1. Isn't that adding a negative 1? Subtraction is just adding negatives. Well, okay. How about multiplying? 3 times 4. How's that adding? You know, huh? How's multiplying really adding? Yeah, add 4 3 times or add 3 4 times. Either way. It's repeated adding. Right? Well, how's dividing? What about dividing? 10 divided by 2. That means how many times can you take 2 away from 10? 5 times. And subtracting is adding. How many times can you add a negative 2 to get to 0? Dividing is how many times you can repeatedly add negatives. Right? And on you go, right it up the line all the way to calculus with the big S. Sum them up. Add them. It's just fancier. Math is just fancier and fancier and fancier adding. That's all it really is. It's just more and more fancy. Everything in the end in math is ways to total things. Add them up. All right. Anyway, getting back to it. So S sub n, when you see the plus signs here, you go, oh, I need the S formula for sum. And here it is. You don't have to memorize it. Give it to you right on the top of the test. You don't even have to put it on your 3x5 card. Wow, it's great, huh? All right, so now let's use it. Here we go. So S sub n is n over 2 a1 plus an. In fact, let me go to a fresh screen because I want to write what everything is for you. So here we go again. S sub n is a1. No, it's not. It's n over 2. a1 plus an. Okay, now what are those? a1, remember what a1 means? First term, right? A sub 1, first term. A sub n, that's nth or last term. And n is the number of terms. N is the number of terms. I want to tell you what the players in the game are. N is the number of terms. A1 and A are the first and the last terms. Okay. So here we go. N over 2. Do I know n? Well, let me skip it. Let me go on. Do I know the first term? How about that? Yeah, that's 11. Do I know the last term? Yeah, 119. Got the first and the last, no problem. Now, what's my n? What's my number of terms? Can I go, there's 4 of them. 1, 2, 3, 4. No, there's a bunch missing, huh? There's that dot, dot, dot. There's a whole bunch missing. How many terms? I don't know. Got to find it. So go off to the side. We've got to go find n, bring it back, plug it in, and finish up. To find n, use the a sub n formula. You actually have to use both formulas on this problem. These are a little difficult. So you got to use the a sub n. A sub n is a1 plus n minus 1d, right? Okay, let's use that one. Now, what's a sub n? A sub n, last term, 119, right? A sub 1, A sub 1, A sub n, right? First term, 11. You with me? A sub 1's first term, A sub n's last term. N is number of terms. So you got to know what these formulas mean. You don't have to memorize it, but you got to know what they mean. N is number of terms. What is D? Yeah, can you see it? It's jumping by 3 every time. Right? D is 3. I just need to solve that equation for n now. Bring it back, plug it into the S sub n formula, and wrap up this problem. That good? I can see my way clear to the end now. Let's just follow the yellow brick road. We'll get there. 3n minus 3. 119 is, what is that? 8 plus 3n. So subtract 8. What do we got? Was it 111 is 3n divided by 3. What's that? 33 and 4. 37? Yeah. N is 37. Plug in the 37. So the number, there must be 37 terms there, is what that means. 37 total terms. So now we can crank it out. What's that? 120, 130. Just hit the buttons on your calculator and tell me what it is. 2405. Thank you. Anybody else getting that same thing? Sounds about right to me. Yeah, good, thanks. 2405. That means all those numbers from 11, 14, 17, just keep adding through every time and then add them all up, all add up to be 2405. 2405. Just like that. Am I good? Questions? So we had to use both formulas. That was a hard one, right? We started with S sub n, because they were being added, some. Wrote it out, but we didn't know. We put in A1 and AN, first term, last term, but we didn't know n. Then we jumped over and used the other formula, A sub n, plugged in last term, first term, and D, difference 3. Solved for n, brought it back, plugged it into S sub n, and wrapped it up. All right, number 18. Try that one, same kind of thing. See how they're being added? So on the next exam, right away, you'd go S sub n. Sum. That's your main formula. You're going to also use the A sub n secondarily, but your main formula is the S sub n. So use that one mainly. So A1 is the first term, AN is the last term, N is the number of terms, right? Good to there so far? Good, good, good. Now I got to get in. So how am I going to get in? Number of terms? Go over there and use the A sub n, which is A1 plus n minus 1d. AN, again, remember that's last term, first term. So last term being 76, first term being 6. And the difference from term, what's the D? The difference, the jump from term to term. It's going up by 7 every time, isn't it? Distribute that. Last step, divide by 7. N is 11. Good? Take that, bring it back. That must mean there's 11 terms there. So we can wrap up S sub n now. So S sub n is 11 over 2. And that, what's that, 82 in there? And then 41, 410, 451. 451, thank you. 451. All those numbers must add up to 451. Good? Questions on that? No questions? We all good? All right. Hey, I got a question for you. Special one. 1, 2, 3, ... all the way to 100. Can you add those up for me? Right? Yeah. Isn't that just what we just did? It's just a series. They call that a series. It's not a sequence, a series. You got plus signs. Do the same formula we just did, right? You're adding up a bunch of numbers. What's S sub n equal? N over 2 A1 plus AN. This will be easier. I bet you can tell what N is. How many terms are there? There's 100. Yeah, right? And A1's first term, AN's last term, right? So we're going to add the numbers 1 to 100 super quick. First term, last term, number of terms, right? So the sum, S sub n, is, so I don't even need to go use the other A sub n formula, because I can just tell what n is this time, huh? Right? If you can't tell, then you have to use the other one on the side. But I can tell there's 100 terms there. No mystery on this one. First term is 1. Last term is 100. Good? Oops, not any good anymore. There we go. Good? And so what is that? 50 times 101. And that's 5050. 50-50. Is that good? We just added up the numbers 1 to 100 that quick. Well, I want to show you that because I want to show you where this formula comes from, this formula we're using. That's the historical setting by which this formula we're dealing with was discovered. Everybody okay with that? Right? That makes sense? I just used the same formula. Carl Friedrich Gauss, 1800s, probably the greatest mathematician ever. Probably him, Newton, or who's the other? I can't remember now. Archimedes or somebody. Anyway, are probably considered the greatest ever. I think perhaps Gauss. I'm no expert on it, but perhaps Gauss. He was in the 1800s, 1700s? I think it was 1800s. 1800s. 1800s, small little village in Germany. and he was correcting mistakes in his father's bricklaying business when he was like 3 years old or something. I don't think I'm exaggerating. You can go on Google, you know, maybe 4 years old, you know, something like that. His dad had a bricklaying business, and he would just correct the adding mistakes and stuff, you know. Then he went off to school, and just right away was just crazy good, you know, just figuring everything out, going way ahead of his instructors and just doing amazing things from, you know, prodigy from a young age. And then when he got to be, I don't know, 14 or 13 or something, you know, his dad wanted him to take over the bricklaying business. Yeah, it was a good thing. The village intervened. The village came and said, hey, you know, Gauss is kind of Carl Friedrich Gauss is kind of a little bit special. Well, they pooled their money together and shipped him off to the university. So he went off to the university, quickly exceeded all of his professors, you know, just figured out stuff they weren't figuring out, you know, just genius right off the get-go, and, you know, the rest. He used to figure out new discoveries so fast that he didn't have time to publish them. In fact, his saying was few but ripe. Few but ripe. Notice, he was like, I'm not going to publish everything I discover because I don't have time to write them up. I'm just going to do the really big ones, right? So sometimes his fellow math science people would run over and say, hey, Carl Friedrich, I figured out this, da-da-da. And he'd go back in his notebook, oh, yeah, I figured that out a while ago. No, that's a good one. You go ahead and publish that. Yeah, you know, he would just figure them out so fast. When I took Physics 4B, I don't know if some of you guys are planning to take the physics series, the calc-based physics. So physics, you got to at least do Calc 1, Calc 2 first. And then Physics 4A is the first one, the mechanics, and Physics 4B is the electromagnetism. That was the hardest class I took at junior college, was Physics 4B, Calc-based Physics 2. Anyway, that was crazy hard. Electromagnetic wave things and circuits and all that, using calculus to do physics. It was pretty tough. Anyway, in that we had 4 equations that were, the whole class was dominated by 4 equations. Gauss had 2 of them. 2 of them were his. I mean, that's just gigantic. Anyway, so he was that big. So the story goes, he was a 4th grader, 3rd grader, something like that. And he was in, it's considered mostly true, you know, as far as we can tell. This seems like, I'm sure there's some embellishments to the story, but in general, he was 3rd or 4th grade. He was sitting in there. The teacher was like, I don't know, mad at the class or just wanted some free time. So the teacher said, look, just take your little slates, right? Slates back then, 1800s, and add up the numbers 1 to 100, like we just did. Add up the numbers 1 to 100. So the teacher just wanted to buy time, right? So, you know, this is what they do a lot in the elementary school curriculum, don't they? Why don't you color in the numbers 1 through 5? Color. What's that for? Are you kidding me? What is that for? You're just wasting my life here, right? Anyway, you get my personal opinion on the state of public education. But anyway, so add up. So they wanted the kids to add up 1 plus 2 to get 3. And then add 3 to get 6, and then add 4 to get 10, and then add 5 to get 15, and then add 6 to get 21. And it's going to take a while, right? Go all the way to 100, and we know what we're going to get, right? Add up all the numbers to 100. Well, Carl Friedrich sat down at his desk with his little slate, and he said, he wrote out the numbers. See on the screen here. 98, 99, 100. Am I on the screen? Barely. Okay, so he wrote out the numbers. And he thought this. He said, what would happen if I just like reversed the list right below? We're going to come up with this formula. What if I just reverse the list? Lot of math and science is discovered by fooling around. Really true. That's what Einstein meant by his quote, for a scientist, imagination is more important than knowledge. What he meant is you try stuff. You use your imagination. You try something crazy like everything travels relative to the speed of light the same, and then you see if it plays out. So Carl Friedrich just said, what if I just like reverse the numbers? 3, 2, 1. Just like that. You know, just reverse them. Okay, great. So what? And then I add them up. Add them vertically, you know, just straight up and down. What am I going to get? 100 plus 1 is 101. Okay, so what? 2 and 99. 101, okay, yeah. 3 and 98. Okay, great. Oh yeah, that's cute and everything. They're all coming out to be 101, right? 101, 101, 101. Okay, so they're all 101. No, actually, that's big, huh? How many 101s do we have there? Yeah, we got one for every slot. We got one in this slot, one in that slot, one in that slot, all the way down to 100. We've got 100 101s. But that's the list twice. That's the list forward and backwards added up. So that's twice as much as we want, so cut it in half. There it is. 50 times 101. That quick. And the story goes, he brought up the answer 50-50 in just like 5 minutes, you know. The teacher went, "What? You cheated!" And dunce cap in the back of the room. That might be the announcement, I don't know. But that's how I heard it. All right, so there's where that formula comes from, yeah. All right, so you know what that Greek symbol is? It's a big Greek S, isn't it? It's a big Greek S. N equals 1 to 120. 2n minus 4. So that's a big Greek S. So what do you think? If you had to guess, are we going to use A sub n or S sub n since that's a big S? We're going to use S sub n, aren't we? That's a big Greek S. That's a sum. Remember that means, in fact, I think it'd be best to actually do a few. Remember that means sum up, use this formula, plug in 1, plug in 2, plug in 3, all the way to 120, right? To that formula, and that add them up, right? You start with this number, you end with that number, right? So take the 2n minus 4 formula, plug in 1, what do you get? Negative 2. Take 2n minus 4, plug in 2, what do you get? 0. Take 2n minus 4, plug in 3, is that 2? Am I going too quick? See what I'm doing? I'm taking the 2n minus 4 formula every time, and I'm plugging in 1, plugging in 2, plugging in 3, because that's what that big Greek symbol is telling me to do. It's saying start at 1, go all the way to 120. Plug in 1, plug in 2, plug in 3, plug in 4, and add them. Right? Then I can do one more. 2n minus 4, plug in 4. 8 minus 4, 4. You get the pattern, right? Plus dot, dot, dot. What's the last one going to be? 2n minus 4, plug in 120, huh? 120, 240 minus 4, 236. Good, that's what that thing's saying. We good with that so far? I still don't know the final answer. I'm just, putting it into something that looks more familiar to me. This is saying that, isn't it? It's saying add up the formula 2n minus 4 as you plug in 1 and 2 and 3 and all the way to 120. So they want me to add this up. So now I use the S sub n formula. Why? Because it's a sum. Because it's added things, right? If it had commas between them, I would use A sub n. Are you getting the difference? They have plus signs. It's a sum. Use S sub n, which is n over 2. A1 plus an is Mr. Carl Friedrich Gauss discovered, right? So n, remember what these players in this game mean? N is the number of terms. This is the first term. This is the last term. So what are the number of terms? Yeah, we don't have to, these are going to be easier actually. We don't have to use the A sub n formula. Look, it's telling us start at 1, go to 120. There must be 120 terms. N must be 120. What's first term? A1? Negative 2. What's the last term? AN? 236. There it is. Crank it out. What's that? 60 times 234, which is some big number. 1424? 14,040? Like that. There it is. Those were all those numbers add up to be. That's what that big Greek symbol is saying.
An easy way to remember to use the S sub n formula in this one is if you think about what's in the parentheses, that's actually the A sub n.
Oh, nice. That is the A sub n. Good observation, Robert. Yeah, this is the A sub n, and you're summing the A sub n. Well said. Exactly. Exactly. All right. All right. All right, let's try that one. Same kind of thing. So take that formula, plug in 1, plug in 2. Well, really, actually, all you need is the first term and the last term, huh? Yeah. So you can just plug in 1 and plug in 120, Find the first term, find the last term, because in the S sub n formula, all you need is the first term and the last term and the number of terms. There's 120 terms, right? Again. plug it in, equals 1 to 8 minus a half n. You can use decimals if you prefer. That'd be 7.5. Half's 0.5, right? And then I'm just going to go dot, dot, dot. And then I'm going to jump all the way to the last. There's the first term and the last term. That's all I really need. 8 minus a half n, plug in 120. 8 minus 0.5 times 20. 60 is at minus 52. That's the last term. And then the S sub n formula is n over 2a1 plus an. So the number of terms is 120. The first term is 7.5. The last term is negative 50. We're going to get a negative answer, aren't we? Yeah, so that'd be 60 times, I don't know, what's that in the inside there? Negative 47? 44.5, thank you. And then you multiply that, it's going to be negative 2,000 something? 2670? All right, it's a big old negative sum. Is that?
I got 3150.
2670?
Yep.
Looks like 2670 is the majority on that. All right. Well, we will stop there. This is not due. We didn't quite finish. So, what do you guys need to do over Easter break without any math work to do? You know what you could do if you get bored in the middle of the week? You can always look back to old YouTube lectures for entertainment, right? Teach them what that math is. So 12.2 won't be due till Tuesday after we get back from break. Have a good spring break. I'll see you in a week from Monday.